So I want to show you a nice, easy trick about rate constants. And here we go. Okay, so rate constants. So if I take a rate law, rate equals K, and I'm just going to keep this as simple as possible. And let's say this is my rate law. And so we'll make this first order. So remember that the rate units are going to be concentration over time. I'm just going to keep it simple and use molarity per second. So whatever the rate constant units are, times however many reactants and their orders are, you have to wind up with concentration per unit of time. All right, so if this is first order, and I'm just going to go ahead and put the 1 up here, we understand that we don't do that typically. So here's the deal. So if this is the concentration of A and its first order, what we have here is molarity, and it's molarity over 1. You can put anything over 1 and make a ratio. Remember that the rate units have to be molarity over time. Now that means that my rate constant units have to be 1 over time, because I need to multiply molarity times 1 divided by seconds times 1 to give me molarity over time, molarity per second in this particular case. So my rate constant units, if the reaction is first order, are going to be 1 over time. Okay? In this case, I used 1 over seconds, which we could write as seconds to the -1. So that's first order, just 1 over time, whatever the unit of time happens to be. Let's change it. Let's do rate is equal to K times A, and let's make this second order. Okay, so we're second order overall because there's only 1 reactant here. Okay, and so remember that this has to be molarity over time, and we're just going to use seconds. And so this is going to be, so the concentration of A is in molarity, but it's second order, so it's molarity times molarity, which gives me molarity squared over 1. So what are the units of K going to have to be? Well, if I'm going to wind up with molarity over time, this has to be 1 over molarity times seconds. So if it's 1 over molarity times seconds, one of these will cancel. And so now I'll again have molarity times 1, which gives me molarity, and seconds times 1, which gives me seconds. So the rate constant units for a second order reaction, so second order reaction overall, they're based on the second order or on the overall order of the reaction, will be 1 over molarity times time, which in this case is just 1 over molarity times seconds, and we can write that as per molarity per second, or molarity to the -1, seconds to the -1. And this is for a second order overall reaction. Okay, how about this? How about I have rate is equal to K times A, and it's third order overall. Well, I think you might get it by now. We have molarity over time, and so this is going to be molarity cubed, and I'm just putting the 1 down here so you can see the little math we're doing here. And so this has to be 1 over molarity squared times seconds. So that one of these will cancel. And so what we'll have for our rate constant units is 1 over molarity squared times time. Okay, and I'm just going to continue to use seconds here. So this would be 1 over molarity squared times seconds, which I could write as molarity to the -2, seconds to the -1. So it's always going to be per unit of time. These are rate constant units. Okay, one more. So here's our rate law. Actually, let's do 2 more. K, A, and this time we're actually going to have a 0 order overall reaction. Well, if this reaction is 0 order in A and 0 order overall, anything to the 0 power, so anything to 0 power is equal to 1, equals 1. So the actual rate law would just be rate is equal to K, the rate constant, because changing the concentration of reactant A doesn't change the rate. The rate is independent of the concentration of the reactant. Well, since rate has to be expressed in concentration over time, that means the units on K would also be concentration over time. They would be exactly the same units as the rate. Now, let me do this last one and hopefully you'll get it. So let's say I had a reaction that was rate is equal to K times A, which would be to the, I don't know, let's pick 38 order overall. Now, keep in mind that the rate units have to be concentration over time. So we're looking for units on K. Well, the units on A, since this is going to be in molarity and it's 38th order, this is molarity to the 38th, and we'll just go ahead and put it over 1. So what can I multiply molarity to the 38th over 1 by that's going to give me molarity over seconds? Well, that's going to be 1 over molarity to the 7 times seconds. Now what happens is all of these go away, and all of these except 1 go away. We're still left with 1 of these. These are all gone. And so what we wind up with, again, is molarity times 1 over seconds times 1, giving us molarity over seconds. So hopefully you see the pattern. Whatever this order is overall, okay, whatever that order is, the units on the rate constant will be 1 over concentration, that is 1 less than the overall order of the reaction times time. Okay, so that's the way that works. So if I had, let's say, an overall order of 54, then my rate constant units would be 1 over molarity to the 53 times seconds, or times whatever the unit of times was. If I have an overall order of my reaction of 16, then my rate constant units are going to have to be 1 over molarity to the 15th times time. Okay? All right. Hopefully you get that, and you'll get that right on the test. Good job.